I said to round down, right? Correct? Okay, good. Now, let's take a look at question number 2 now. We are continuing on the full scale. Don't make me shout at you. Number 2 now. Suppose you are an engineer tasked to design a multi-story car park. The height restriction for vehicles entering the car park is calculated to be 2.51. 2.51 meters. That means the restriction is what? The maximum, right? That can get it is 2.51. Okay? A sign indicating the maximum height correct to the nearest meter is to be placed at the entrance. What should the maximum height be shown as? Explain your answer. Okay, all of you look up. They want a sign that is correct to the nearest meter, right? Now, why it should be 3 meters, right? You will round off. But can I put it as 3 meters? No, why no?
Because then you ran the roof.
Correct. That means if let's say if I put 3 meters, right? If the vehicle is 2.6, then it will grow. Alright. So what should the sign say? How many meters? 2, yes. Oh, must say 2 meters. Am I right to say that? Do you understand my logic here? Yes or no? So sometimes you got to look at the question in order to answer properly. Okay? Next one I'm going to look at is question number 4. Continue all this on the full scale. Don't later say don't know. This is what are you trying to do? Okay? Now number 4. The area of a square is 264 cm squared. 264 cm squared. Find the length of the square. Okay. I want you to draw this figure and put the length as L. All of you draw this figure and put the length as L. Later I'm going to collect the full set. Where's the full set? The other day we did one question today. You're supposed to continue on the full set. Donate one full set to him. Alright. Now let's look at part 1. The question says what? Find what? Find the length. Now all got here. Do you agree that L times L must be 264? That means this one is L squared is 264, right? We did this before, right? So how do I get L? Square root of what? 264. Okay. All of you key in your calculator. What is the square root of 264? 16.24806. Now, your calculator says this, I'm going to read you now again. 16.2480681, right? You don't write down everything, I say working must be given to what? 5 figure, truncate. What's truncate? Cut off. Okay, so 1, 2, 3, 4, 5. Cut off the left. So this will be 16.248. But the final answer must be given to 3 significant figures. So it will be 16.2 cm. This is what we must do. Understand? Okay. Now, next, part 2. What did the question say? Find what? Find the parameter. Okay. So, next. Parameter must be 4 times the length, right? Right. Do I take this one or this one? The top one or the bottom one? Top one. So, you must take 16.248. Okay, key your calculator. 64.992. Okay. This is not the 3 significant figure. And this one was also rounded or Are we clear now? I'm also revising cylindrical figure. Can you see that? Okay. So that will be a question 4. Next, I'm going on to question 5. Okay, I'm going on to question 5. Circumference and area. Now, I want you to write down the formula first. Circumference of circle, the formula is either pi d or what? 2 pi r. Circumference. Pi d or 2 pi r. What's pi d? D is what? Diameter. How come this 2 is equivalent? Because diameter is how many radius? 2 times of radius. Can you see? I think your parents will actually tell you that now. Okay, now, what about area of a circle? Pi r squared. What's the meaning of r squared? R times r. Correct? R times r, correct? Index notation, remember? Okay? Alright, good. Let's look at the question now. The circumference of a circle is 136 meters. Find the radius of the circle. 2 pi r is 136. Right? Alright. I want to find radius. This will be a 136 divided by 2 pi. Am I right to say that? Okay. Now, can you key the calculator? What's 136 over 2 pi? No, divide by 2 pi. That means you key the numerator, denominator, that one. Okay? Okay. Give me the 5 truncate. So it's 21 by what? Yes, good. 21.645. 3 cylindrical figure. 21.6. Don't forget it's in meters. The radius. Okay? Alright, next. Part 2. What about the area? They're asking for the area. Area is what? Pi what? Pi r squared, right? So this will be pi times the radius squared. What number do I use? 21 by what? 645. Very good. All of you key in this. You will get a 1471.855. I need to reiterate this. No, I say that working all the 5-figure truncate, right? Now, can you see this is a very big number? I told you if it's a very big number, you need it to what? 3 decimal places. If not later, let's say you have this 14715.7.347. That's it. Can you see 1, 2, 3, 4, 5? You don't truncate, no? Then it becomes wrong already. You understand? Give the 3 decimal places, okay? So, if I change this to 3 significant figure, all of look up. 1, 2, 3. What should it be? 1, 4, 7, what? 0, yes. Meters squared. Understand? Understand now? Then, so that will be your question number 5. Okay. Are we clear so far? Are we clear so far? Okay, good. Now, next, I want to look at question number 10. All of you look at question number 10 now. Okay? Find the area of a rectangular field measuring 27.04 meters by 20.21 meters. Okay, I want you all to roughly draw a is what? 27.04 meter. The width is 20.21 meter. The question says find the area of the rectangular field. So area will be 27.04 times 20.21. This is an exact answer. Can you see? It's a terminating decimal. Can you see it's terminating? What is the final answer that the calculator gives you? 546.474. Is it correct? 4784. Okay, good. 84 meter square. Now this one is an exact answer. We do not truncate or we will not round off. Understand? Because it's an exact answer. Okay, now then people will ask me, Cher, isn't this also exact? But do you think this is exact? No, because from here, this one we truncated. That means this is already not exact. So, not exact, this one cannot be exact. It's also sort of an estimated value. Do you understand? But this one is confirmed of exact value. Understand? So, we do not roll off three decimal figure. Are we clear? Okay, alright, next part. Part 2. How much would it cost to spray insecticide on the field if the rate is 70 cents per square meter? Give your answer to the nearest dollar. Okay, I'll teach you one way to present this. And I always use this way, alright? 1 meter square costs 70 cents. So I have 546.4784 meters square. It will be 70 cents over 1 times 546.4784. Correct. Now, where did I get this method from? Remember I told you this before? 4 apples cost $2. Oh, look here first, don't for me. 7 apples will cost 2 over 4 times 7, right? This over this times this, right? Remember? This over this give me what? The cost of what? 1 apple times 7. Okay, so what is the meaning here? 1 meter square is like that. This over this is 1 meter square cost, right? Then I times this, I will get the answer. Okay? Now, you give me the whole thing first. On your calculator. On the calculator, it should give you 382.53488, right? Alright now. Now what did the question ask for? Must always be the question. The question asked for nearest one. Give to the nearest one. Dollar. Dollar is where? Here, right? So how much is it? 383, right? Agree? This is the nearest dollar. Okay? Now what if the question never say anything? 2 decimal place. That means you must give me 382.53. Understand? If they didn't say anything, money must be given to the nearest cent. That means 2 decimal places. Are we clear with what I'm saying here? Okay? Now I will collect this later, not now. Alright? Because I still want to discuss 2 questions with you. These 2 no need to pick up. Understand? These 2 no need to pick up. Okay. Alright. Can all of you now look at question 3? It's just for discussion. Okay? Just for discussion. Alright? Because when you go out to the real world, you're not just do maths like you do on the textbook. Right? Okay, you must also know what the real world is about, right? Now let's say question number 3. Let's look at the question. The items you buy at the supermarket amount to 70.69. After informing the cashier that you will be paying in cash, she rounds down the amount to the nearest 5 cents instead of rounding the amount to the nearest 5 cents. Now, rounds down and round off. Okay? It's different now. Understand? Look at the question. She rounds down the amount to the nearest 5 cents instead of rounding the amount to the nearest 5 cents. Okay, question 1. What is the difference between rounding down the amount to the nearest 5 cents and rounding the amount to the nearest 5 cents? I'll give you some examples on the board so that we are clear about it. Okay? Now, let's take a look at the board. Okay. Now, I'm talking about rounding down to the nearest 5 cents first. If it is 17.61, if I round down to the nearest 5 cents, it will be 17.60, right? Alright. Because let's say the cashier only got 5 cents denomination, you don't have 1 cent, okay? How about 17.62? It will also be 17, right? 60, right? How about 17.63? Also 60, right? What about 17.64? It's also 60, right? What about 17.65? Then it will be 65 because they got 5 cents. Understand? All this is being rounded down. Now, what about 17.66? Will be round down to 65, right? What about 17.67? Also 65. All these are also what? 65. This is the meaning of rounding down to the nearest 5 cents. Now, what do you mean by rounding off to the nearest 5 cents? Rounding off to the nearest 5 cents. That means this one will be what? 70.60, 70.60, 70.60, 70.60. This is still 17.65, right? Correct. 5 cents mark. Rounding off mark off. But how about here? This one will be what? 70.70, right? This one will become here, right? Nearest round off. Correct. How about here? Also 70.70. Agree? Correct. So that's the difference. Do you understand? Can see it? Okay, Now, so what's the difference? This is the difference. Now, part 2. Why does the cashier round down the amount to the nearest 5 cents instead of rounding the amount to the nearest 5 cents? Why do you think that they round down instead of round off? Do you agree that if they round off, right, the company will actually earn a lot more? Because even if it's 66, I count 70 cents, so 4 cents more. If everyone they earn so much more, that means the company will earn a lot more. Do you understand? You understand? So therefore, okay, in order not to charge the customer more, the business owner will actually round down. You understand? You follow what I'm talking about here? Are you okay? Cannot. Okay, good. So I just want to discuss this with you. That's all. There's nothing serious about it, but you should know what's happening in the real life. Everybody okay? Alright, good. Next day, can we look at question 18 on page 18? Question 18. Okay, let's look at question 18. Okay, let's read the question first. Shop A sells a pair of shoes at 80/50 before a 20% discount. So let's look at shop A. count? 10. Okay? Without using a calculator, use estimation to decide which shop to buy the shoe from. Show your working here. Okay. Now, from here, right? How much is 10%? Can you tell me? For shop A, how much is 10%? 805. Do you agree it's 805? So how much is 20%? 1610, right? Do you agree that the discount is 1610? Correct. So if I have $80.50 minus 1610, I'll have how much? 440, right? Correct. Actually, can you see I don't need to use calculator? Actually, I can do some mental sum. Okay. How much is 10% from here? 6 what? 6.95, right? We agree? 6.95, right? So 10% discount is actually 69.50 minus 6.95, right? Agree? Yes or no? Okay. So this will be a 4. This will be a 5. What's this? 61. 62.55, right? Did I make any mistake? Did I make any mistake? No, huh? Okay. So, which one should you buy it from? B, right? Now, let me give you another scenario. What if someone don't want to say 6.95? They say 10% is $7. Is it okay? Around $7. So, 69 minus 7 is how much? 62.50, right? Around there also. So, no matter what, can you see it's still cheaper than shop A? Can you see? So, we should buy from shop what? Shop B. Are we clear now? Are we clear now? So, there's no need to use your calculator in front of the cashier and start calculating that sort of thing. Then do some estimation. Everybody okay? Everybody okay? Okay. Alright. Now, so that's all for this part. Okay? That's all for this part. Now, I want you now to pass forward your exercise 3B. Pass forward your exercise 3B. And also pass forward your maths file. Those who have to pass forward your maths file. I should have 30 pieces of foolscap paper and 24 files. The front row, one person collect file, one person collect foolscap paper, so that it's not so confusing. Okay? Any more? You don't have to worry. I will take care of those people who don't have it. of foolscap paper. That is correct. Okay. I should have 24 files because 6 of you say you can't get in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 2 more. Oh, 24 is correct. 6. Oh, I mixed it. No mind. That's really funny. Okay. Now, I'm also not too happy that the class is not handing in the correction on time. Understand? Your 3A correction is to the Benjamin. Benjamin, you need to be my tray by 12:40. Okay? Alright? Now, so far, I've already finished chapter 1 and chapter 2 as well as chapter 3. Let me just summarize what's chapter 3. Chapter 3 tells you about how to round off to the nearest 10, 100, that kind of things, okay? How to round off to 1 decimal place, 2 decimal places, and the most importantly is the significant figures. Are you clear? Okay, and the second part of chapter 3 is to tell you how to estimate things. Alright? And as I've said during the last lesson, different people have got different ways of estimation. Okay? There's no one specific way, it depends on which one you are more comfortable with. Are you clear with what I'm saying? Okay, now next I'm going on to a very important chapter, and that is called Algebra. Okay, chapter 4. Now for Algebra, right, you must be very good in Algebra if you want to take additional mathematics when you are in Set 3. Okay, next year we will also have a lot of Algebra. But please do not mistaken that Algebra is only required in A-Maths. E-Maths we also have Algebra. Just that it's not so tedious kind of work. Everybody clear with what I'm saying? Okay, now actually there's nothing to fear about Algebra. All of you look at what now. I'm going to introduce to you. Let's say 1 plate of chicken rice is $4. Okay, 1 plate. How about 2 plates? $8. How do you get $8? 4 times 2, right? What about 3 plates? $12. What about n plate? 4 times n. Okay. So what does n represent? N represents an unknown number. Okay. So in algebra, the letter just represents an unknown number. Everybody clear? Okay. Now, when we have 4 times n, we can write it as 4 times n like that. And the answer should be 4n. Number in front, letter at the back. Nobody needs to write n4. Do you understand? Or what two words like this? Everybody clear? Number in front, letter at the back. Okay? Alright, let's turn to page 92 now. Page 92. Basic algebra concepts and notations. Now, in algebra, letters are used to represent different kinds of numbers. Okay, let us look at an example. There are some sweets in the box, and Imran ate 3 of them. We can let the number of sweets in the box be x, and there will be x minus 3 sweets left. In this case, the letter x represents a specific unknown number, correct? Correct. That means in the box, you know how many sweets are there, so it's a specific number. But number of plate of chicken rice sold is not specific. It depends on how many customers will buy. Okay, so it depends. Alright? Now, next. Without further information, we will not be able to find unknown x. However, if we know that there are 7 sweets left, then we can find the unknown by drawing a model and forming an equation as shown in 4.1. Now, I know in primary school you are expert in drawing models. Okay? But model is not the best way to solve questions. Questions could be crafted in a special way in order to solve it by models. Okay? But algebra is the universal way to solve a problem. Understand? So algebra is actually more powerful than model. Okay? So you must transit yourself from model. You are going to do algebra now. Understand? And I'm going to introduce to you. Okay? Now, let's take a look at page 93. Okay? It's using letters to represent generalized numbers. Okay. Now first, we must know something number A plus B, and I do B plus A, do you think the answer will be the same? Yes. So A plus B and B plus A are the same. Just like you see, 2 plus 3 and 3 plus 2, the answer is still 5. So they're equivalent. Okay? Now, then I want to ask, what if I have A times B and B times A? Are they the same? Yes. So this one is still equal. AB and BA means the same thing. Okay? Now, then one more question. What about A minus B and B minus A? Will they represent the same thing? Will they represent the same thing? No. This one is not equal. Because you see, when I have 7 minus 2, right? What's the answer? 5. But when I have 2 minus 7, what's the answer? Negative 5. It's a different thing altogether. Don't say, what, number same now? No. This one means you have $5. What about this? You owe people $5. It's different. Or you have money, you can go and buy things. You owe people, you can punch you. Understand? Okay? Alright, so let's take a look at page 93. However, not all letters in algebra represent specific unknown numbers. We also use letters as generalized numbers. Okay? So, look at the property down there. A plus B is equal to B plus A. Are we okay? Then, one more situation. If I have A divided by B, do you think it's the same as B divided by A? Do you think it's the same? No. Alright? So it's only true for what? Addition and multiplication. It is not true for subtraction and division. Are we okay? Now, can we take down these 4 things at the bottom of page 93? Now, all of you, I'll give you some time. Next, we are going on to page 94. Okay? Using letters to represent variables. Now, what do you mean by variables? Variables means the number can change. It can vary. Understand? Okay, let's take a look at page 94. In primary school, we have learned that the perimeter of a square is 4 times its length. This relationship between the two quantities, perimeter and length L of a square, can be represented by using the letters P equals to 4 times L or 4L. Correct. Now, P and L are called variables. Why? It depends on what is the length of the square, right? If the length of the square is 3 cm, perimeter will be what? 12. What if the length of the square is 4 cm? The perimeter will be what? 16. So, they can vary depending on the size of the square. Everybody clear? That's why it's called variables. Okay? Alright, now next. P also varies. Alright? Over, if a value of L is given, we can find the value of P and so on and so forth. So, we can use letters to represent formulas. Understand? In primary school, it's all about formulas also. Am I right to say that? Okay? Now, algebraic notation. Okay, now I need to specify this back so that you know. I need to talk about this first. If not, you don't know how to simplify and so on. Okay, what is x plus x plus x? The answer is what? 3x, right? Correct, the answer is 3x, right? Okay, so this is one of the notation. What What's the meaning of xy? X times y. Is it the same as yx? Yes, it's exactly the same. Then ask me, then if I write yx, will you mark me wrong? The answer is no, I'll mark you correct. The order is not important. Understand? Then another situation. In algebra, when we write divide, usually we write like that. X divided by y. Do you understand? X divided by y. Now, another one is an index notation. What is a times a? What will it give you? A is power, right? Because 2 times now. What about a times a times a times a? A to the power of what? 4. Okay, so this one will tie in to your index notation. Are we clear so far? Okay, good. Now, next. Alright, I'm going to talk about coefficient and so on. Now, I'm going to talk about it here. All of you look up. I give you an expression. This is the term in xy. This is the term in what? X. What do you call a number? A number is called a constant or a constant term. Everybody there? Or a constant term. Now, let's say I have 3 here and I have negative 4x here. The coefficient of xy is 3. That means coefficient means what's the number in front of it. Okay, it's 3. Now, then I want to ask, what is the coefficient of x? It's not 4, this one. Negative 4, very good. Understand? Then what is the constant term? Will you follow? Can you see? Now, if this is like that, can you tell me what's the constant term? Negative 14. So you must know. Coefficient is the number in front of that term, but it includes the sign. Understand? Constant term is the number without any variables. That means without any letters. Everybody okay? So the number in front of the term is called the coefficient of the term. So in this expression, how many terms do I have? 1, 2, and 3. There are 3 terms. Everybody clear now? Everybody clear now? Okay. Now I'm at page 96. Alright? Algebraic expressions. Okay? In general, an algebraic expression is an expression containing letters, numbers, and operations, and has no equal sign. Okay, then they give you some example, constant term, can you see? And they also say coefficient, can you see it? I've explained all that on the board already. Okay, coefficient, constant term, and so on. Now, I'm going to give you another example. Can you tell me in this expression, this is called an expression, how many terms are there in terms? How many terms? 1, 2, 3, 4, and 5. There are 5 terms. Everybody okay? What is the coefficient of x squared? 5. What is the coefficient of y squared? Don't tell me it's plus, but there's nothing here, this one. There's a 1. What's the coefficient of y squared? 1. What's the coefficient of x? Not 3. Negative 3. What's the coefficient of y? 5. What is my constant term? Negative 4. Are we clear? You must be clear. You cannot mix up one. Everybody alright? Everybody alright? Okay. Alright. Now, next. Can we all now turn to page 98? I'm going to do work example 1 together with you first. Okay? Work example 1. Evaluate each of the following expression. 3x minus 2y, 2y over 3x. Now, I already told you, right? What's the meaning of evaluate? Find the value of. Very good. Now, how do we present this kind of working? Okay, everybody will come here. Cannot just anyone how give me the working. Alright? You must write A, 3x minus 2y, right? So, 3, what is my x? 5. You put bracket like that. Minus 2, what is my y? 3. Negative 3, right? Okay, then you can punch your calculator. All of you punch down. What's the answer? Okay. What's the answer? 21. Alright now? Now, in exam, you must present this step. Everybody clear? Okay. Let's look at part B. 2y over 3x will be 2 into negative 3 over 3 into 5, right? Final answer? Negative 2 over 5. Alright now, you will tell me, Joe, if I put negative 0.4, is it okay? The answer is yes. But try to give it in fraction. Because in case it's a recurring decimal, then it's going to be very difficult. Do you understand? So try and give it in fraction. Okay? Now, next thing, I'm going to talk about linear expressions. What are linear expressions? Just for your information, no need to go and memorize. Alright? Linear expressions will be things like 2x. Can you see this one? Only got x, don't have power. Or 2x plus 4, which is also linear. It can also be 2y plus 7, also linear, because only got one, the vector, without power. Okay, what about this one? X plus 3y plus 8. This is also linear. Can you see? Power 1, power 1. But I got 2 variables, that's all. All these are in 1 variable. That means only got 1 unknown. Understand? Now, what do you mean by non-linear? Give you an example of non-linear. For example, 3x squared plus 4x plus 3. Can you see this is the power 2? Once got power 2, not linear anymore. This is called non-linear. Understand? Another example, 3xy plus 4. This is also non-linear because we have 2 variables thumbed together. You understand? Okay, just for information. Alright, don't have to memorize this. Just for your information that linear means 1 variable without power. Okay, the power is always what? 1. If you don't write anything, don't you agree the power is 1? Alright, it's an invisible one. Okay, so these are called linear expressions. Alright, and it is found on page 98. Alright? Look at the last statement there in the box. 4x plus y minus 8 is a linear expression in 2 variables x and y. Okay, now next I need to talk about like terms and unlike terms. You can only combine like terms in plus and minus. Okay, now I need you to look at the board now. Okay, I'm going to end soon. Okay, I'm going to continue on Monday. Are we clear? Now I know you're tired. I'm also tired. YK? Huh? I'm also tired. Understand? Okay. Now, all of you look up. 5a plus 6a. Can I add these two? Yes, because they are like terms. All together, 11a. What if I have 5a plus 6b? Can I add these two? No, because they are unlike terms. We can only combine like terms. Okay, then I'm going to ask you. are the same. Okay? So what is this? 13 what? A, B or A, up to you. Everybody clear? Okay, then comes the important part of the algebra. Like I say, you can only combine like terms, you cannot combine unlike terms. Okay, let me just refresh this first. 6A minus 2A. Answer? 4A, very good. Minus 6A plus 2A. Negative 4A. Why? You owe people 6 apple. You have 2 apple. You still owe people 4 apple. That's how you think about it. Okay? Negative 6A minus 2A. Negative 8A, right? Why? You owe people 6 apple, then you owe him another 2 apple. Altogether, owe him 8. Everybody understand? It's just the same as numbers. Okay? Next one. Okay? Answer? A. Now I know it's 1A, but we don't usually write the 1. It's invisible. Are we clear? We can only add or subtract like terms. Unlike terms we cannot. For example, this is cannot simplify, already simplified. You understand? Because say I want to combine, cannot. No such thing. Okay, now what about this? Two A, because they are called like terms. Are we clear so far? So we can only combine like terms. We cannot combine unlike terms. Everybody clear? Okay, now I want you to go through this again during the weekends. Next Monday, I'm going to go through this with you. Is that clear to everyone? And those people who forgot to bring the files, please bring the next lesson. So now stop the video.